Today's lesson, the ninth in the series, is what's known momentum. So we often hear something has momentum, and so what do we actually mean by that? Well, what we actually mean that is reluctance to change. Alright, so something likes to keep on going, and what do we know about things that, if we want to change them, is that if it's faster, it's harder to change. So the faster you're going in your car, for example, 100 kilometres an hour, it's harder to stop than it is if you're going 40 kilometres an hour. So, and also mass. More mass, again, the harder it is to change. So there's momentum wraps these two things together. And so momentum, which is a vector, is equal to the mass times the velocity of something. So you need to treat it as a vector. Now its units are not very creative, imaginative, I suppose. It's just to simply combine the units of mass and velocity. So kilogram metres per second is our units for our momentum. All right, so don't forget these arrows up the top here, vectors, so you've got to treat them as vectors. All right, so interesting thing about momentum is that in a closed system, and by closed system means no outside influence, then the momentum before a collision equals the momentum after. Now, if there are things in the collision, the momentum, how it's distributed amongst those things may be different, but it's the same. So what we would say is that the sum of our momentums, initial momentums, and the sum of our final momentums, it's pretty ugly looking F, final momentums is equal. Alright, so that's provided there's no outside influence. Alright, so let's look at a couple of examples. Alright, so here we go, a railway truck mass 80 grams. So here's our truck 80 grams, and 80 grams is 0.08 kilos. Travelling at 15 metres per second, which is 0.15 metres per second. Collides with one that is not moving at all. And then it says the two trucks become coupled together. What is their common speed? Alright, so the momentum before, well, there's two bits to it. There's this truck here, and its mass times velocity, 0.08 times 0.15, plus this one here, and it's 0.09 times 0. So our momentum initially is just the 0.08 times the 0.15, which is 0.1012. I got that wrong. All right, whereas, so that's our initial momentum. So now our final momentum would be our mass, and now this time we've got those two things that have joined together. So our mass is 0.08 plus the 0.09, which of course is 0.17. So when we go to figure that out, it's 0.17 times v, whatever that velocity is. All right, well, what do we know is that our initial momentum and our final momentum have got to be equal. 0.012 is got to be equal to 0.17v. So the velocity is got to be 0.012 divided by 0.17, which is 0.07, 1 to 3 decimal places, meters per second. And if we translate that back to centimetres per second, which was what was in the question to begin with, where are we? Is now 7.1 centimetres per second. So it's actually going slower, which makes sense because the mass that's moving is greater. All right. So let's have a look at another example. All right. So in this example, a mass of 5 kilos moving at 2 metres per second collides with a mass of 3 moving at 3 in the opposite direction. So let's look at this for example. So we've got that one that's 5 going this way at 2. We've got this one that's 3 going that way at 3. 2 up here is not very good. Let's rub that out. Do that again. All right. And then after, so that's what's happening. And then after that, the mass, 5 kilo mass, rebounds. So if it rebounds, it's going this way at 1 metres per second. And find out the 3, which velocity it's going at. Now I'm just going to work on an assumption that it's going that way, and we'll see what happens. So first of all, what we need to do is we need to assign a direction as being positive or negative. And so what I'm going to do is assign to the right as being positive. All right, so if the right is positive, that means these two values here will be negative when we put it into the equation. So momentum is what we're after. So initial momentum. All right, we've got this one here, which is 5 times 2, plus we've got this one here, which is 3 times, and don't forget the velocity here, this velocity here is in the negative direction to the left, so times -3. So 10 minus 9 is equal to 1. The final velocity, alright, so again we've got our 5 kilo one, but it's travelling in the negative direction. So 5 times -1 plus, and then we've got our 3, and 3 times whatever the v is, and that's what we're trying to find out, 3 times v. Don't need to worry about the sign here, that will work itself out. So our final momentum is -5 plus 3v. Now, what do we know? What do we know is that the initial momentum and the final momentum have got to be the same. So we know that 1 has got to equal to -5 plus 3v. Add 5 to both sides. Then 6 has got to equal 3v. So v has got to equal 2 metres per second. And it's positive, so it's 2 because I've defined the way positive the way that I have. Velocity of the 3 kilo mass is not the direction that I've drawn it here. It's actually it's not the direction I've drawn it, but the other way around. All right, so there's some text questions, page 196.